To your attention is presented a report on the topic Assessment of the Hydro-meteorological Conditions Impact on the Combat Troops Operations Preparations and Conduct in the Geo-information Subsystem of the Automated Battlefield Management System. In the current conditions of the development of the Battlefield Management Systems, BMS, the ability of management bodies to quickly, automatically, and impartially receive information and perform a multifaceted analysis of the situation to support the process of decision-making at all structural levels acquires a special relevance. The effectiveness of the operation of troops is significantly dependent on the correctness of the assessment, among other aspects of the weather. Modern computer and telecommunication technologies provide ample prospects and services in the matters of assessment of HMC. The objective assessment and consideration of HMC is carried out using data provided by the units responsible for hydrometeorological support, which is one of the types of operational combat support. The ability to assess the impact of weather conditions of the types of personnel, equipment, and weapons, terrain characteristics are now partially implemented in battlefield management systems of advanced countries. In this process, the emphasis is put on obtaining the data detailed both in terms of content. The battlefield management systems of NATO countries consider about 40 different weather parameters, and in spatial detailing to the level of individual areas, and temporal, weather forecast for 3 hours, and the assessment of weather impact in short time perspective, weather aspects. Now the feature of these systems is the widespread use of both special and general purposes Internet geodata services, as well as widespread use of both military geo-information systems for data integration. The new means of obtaining hydrometeorological information, methods of its assessment, and the practice of its application in the BMS for units and subdivisions of the land forces of the armed forces of Ukraine, and in particular in military geo-information systems, GIS, are still little known in Ukraine. Therefore, existing implementations of such systems require a comprehensive analysis and adaptation to the realities of the armed forces of Ukraine, with the prospect of further refinement and implementation. The purpose of this article is to analyze the abilities of modern information technologies to solve one of the important tasks in the activities of military command, namely the analysis of the HMC. This task is part of the battlefield decision-making process and is implemented using modern information and telecommunications technology. To achieve this goal, an analysis of the requirements of NATO regulations and standards in force in Ukraine related to HMC, as well as geographic information services and Internet technologies for obtaining and processing hydrometeorological data is needed. The main sources of data are meteorological, synoptic, and aerological stations, meteorological satellites, meteorological radars, various automated and experimental observation subsystems, observations from aircrafts, buoys, and others. On the figure 1, we can see the systems and methods of measurements of hydrometeorological climatic observations. We propose the structure of the battlefield management system, which contains special geodata service for estimation of HMC that will functionally provide practical solutions to automate the collection, storage, processing, and presentation of relevant operational information. Actual and expected changes, the state of the environment, warnings about dangerous and natural hydrometeorological phenomena in the interests of troops. Therefore, it is proposed to include a geodata service to assess the impact of hydrometeorological conditions in the structure of the Geo-information Subsystem of the Battlefield Management System for units and subdivisions of the Armed Forces of Ukraine, as shown in the figure 2. The general-purpose Geo-information Subsystem in the BMS will be used for input, processing, and analysis of data that have a spatial component, as well as to automate the development of combat graphics and electronic maps by tracking all changes in the situation and their operational display. That is, this subsystem is aimed at comprehensive support of decision-making processes for combat operations, their planning, as well as the management of their use of troops and weapons. The development of the order of support of decision-making on estimation of the HMC after the reception and the analysis of the information by officials should be carried out in several stages, as it is shown on the slide. The first stage is the choice of the combat area, the formation of time intervals for the receipt of the hydrometeorological information for the period of execution of tasks by units. The second one is the definition of evaluation criteria and indicators. The impact of actual and expected projected HMC on the use of weapons and units in the combat area is assessed during impact indicators, which can be classified into different groups to establish the eligibility criterion, according to which conditions are considered appropriate if all partial indicators belong to the adequacy region and do not exceed the allowable values. This assessment serves as a basis for choosing the best alternative. Because of the impact of HMC on the combat capabilities of units and subdivisions, the use of their weapons is versatile and multifaceted. Its degree depends on the actual values of hydrometeorological elements and phenomena. Figures 1, 3 in the table show the indicators and levels of assessment of HMC impact on maneuverability combat capabilities for units of the armed forces of Ukraine, as well as their use of the weapons, the sustainability criteria of which are assessed as favorable, transitional or threshold, and adverse. The third one is the formation of a set of indicators and assessment of the impact of HMC. The formation of a set of HMC assessment indicators consists in the automatic selection of HMC assessment indicators from the database array for a certain combat area. Each HMC indicator contains characteristic values, maximum, minimum, average, that characterize their impact on the combat capabilities of units and the use of weapons and military equipment. The fourth one is the assessment of decisions. As a result, based on the integral assessments of the HMC, sections of the final document with conclusions on the assessment of the situation are formed. For each variant of the scenario, a typical set of protective actions and measures to ensure hydrometeorological safety in the activities of troops and operations of WME in the area of combat operations is developed. Also, as recommendations for choosing the optimal plan for the functioning of units and subunits of the armed forces of Ukraine, taking into account the entire range of possible weather conditions, is developed. Conclusions. So, the analysis of the requirements of NATO standards for the study of HMC, as well as geographic information and internet technologies for obtaining and processing meteorological data, was carried out. Some of these services are focused on compliance with NATO military standards. The United States. The structure of the Geo-information Subsystem of the BMS for units of the armed forces of Ukraine, which contains a special location service for assessing the impact of hydrometeorological conditions on the use of weapons and combat capabilities of troops, forces according to the criteria of sustainability, is proposed. The methodology for assessing the impact of hydrometeorological conditions on the training and conduct of combat operations of troops for the Geo-information Subsystem of the Automated Battlefield Management System. This subsystem, unlike the existing ones, takes into account the assessment of the impact of the HMC on the use of weapons and combat capabilities of troops using special software weather service, which makes it possible to quickly supply hydrometeorological information to commandment bodies deciding on combat operations. Within the framework of the recommendation and prospects for further research, it is worth noting that this material can serve as the basis for solving optimization problems of information usage in decision support systems to ensure hydrometeorological safety of troops. Thank you for your attention.